Hello guys, so welcome to the first tutorial of the math subject SGRE. So we keep going to number 40. Okay, so S is basically S is a set of all functions from real number to real number considered to binary operations. So one is the addition, one is the composition. So this problem is very simple. That just ask us about all the common sense of the functional process. Okay, so the first one he asked about a composition is commutative. So basically, this is common sense that the composition of the function cannot be commutative. So simple example is like you can choose any function you like. Suppose like x, and g can be like x squared. Maybe x plus 2 squared. This is s minus 3. And so g composition f is x minus 1 squared, but f composition g is s plus 2 squared minus 3. So they are different. So the number 1 is false. Second, the plus and the composition satisfy the distributive law. This is also the common sense that this is not correct, because the first one is not correct. So if you add the two functions together, then the composition cannot be distributive. So this problem is also easy. Okay. And the third, the plus and the composition satisfy the right distributive law. And this is correct. This is correct. Basically, the third just use the definition. So only the third is correct. So this one we choose C. Okay. 41, the L be a line in the intersection of the two planes, and the equation contains 0, 0, 0. And he asked about the equation of plane if it contains 0, 0, and the perpendicular to L. So basically, you have two planes, and you have a line. They intersection have a line, and your plane is perpendicular to this line. So basically, you know that the normal vector of the plane is just the direction of line L. So once you know this, the direction of line L is very simple, because direction of line L should perpendicular to two planes. So L will proportion to the outer product of the two planes. So we just write a normal vector and compute this. So what all we got is 2x plus. So the plane, the normal vector is 2, 0, minus 2. Or you can write 1, 0, minus 1. So the plane is x minus z equals to 0. Okay, very simple. So we choose A. Okay. So 42, this problem is famous that in the topology or the advanced analysis, you can go. So I will leave the link below that you can go to check. Basically, this is mentioned in the Apostle and the routines analysis course. So this is called discrete topology. Basically, the z plus be a set of positive integers, and you define a matrix if 2 points are the same. and distance 0. If 2 points are different, then it's 1. He asks about the results. So basically, the common sense in the discrete topology is all sets are open. So once you know this, then you can answer all of that. The reason is that since for each point you can write down the ball, which your radius will have. So in this ball, there's no other points. So basically, all of the points inside this ball falls into the set, falls into the set itself. So basically, every point in any non-empty subset, is open. So it tells you that all sets are all open. Okay. So the first one is correct. How about the second one? Since all sets are open, so all sets are closed. The reason is because F is open. If and only if F closure is F complement is open, is closed, and F is closed if F complement is open. Since every sets are open, so every complement is also open. So every set is also closed. So 2 is correct. How about 3? 3 is very simple. Remember that F is continuous if F inverse V is continuous, is open for all open sets V. Suppose F is from X to Y, and V. Since every set is open, so any set of F inverse V is also open. So the third is correct. So 1, 2, 3 are correct. We choose E. Okay, now we go to 43. It gives you the two curves, like XY parameterization, and ask about the derivative at A80. So the first one is we try to find T. So the first equation tells us this. T equals 2 or minus 4, and then you plug it, T equals to 2, this is valid. So T equals to 2 is what we have. Since so the question also tells us that the T should be larger than 0. So T equals to 2 is what we want. Okay, then we can calculate the derivative. So we first calculate the first derivative by simple chain rule. So dy dt dx dt, this is 6t squared. Also in dy dx dx equals to dt dx dt dt dx dt dt and 6t squared. So the first one is 1 over dx dt, 2t plus 2 is 12t. So plug t equals to 2, we get 24 minus 6. Then answer is 4. So we choose A. I think there is no question. We keep going. Okay. So we need 44. 44 is the ordinary differential equation. If you learned how to solve the first order ordinary differential equation, then this problem is really simple that you can directly solve it. So I will show the step by step. Okay, so how to solve this? We first need to find a so-called exact integrator, or maybe the name is not correct. But basically, we need to find some function m such that my prime times mxy mx. This is the total derivative called dmy. So this tells us that m prime over m should be x. So we can integrate this one. We get ln m equals to x squared half. So m is exponential x squared divided by 2. Okay, so this is very simple that we can solve it. We just times exponential half by this one. And this is d exponential half. And then we integrate both sides by x. This is d over dx. So we got this. And this can be integrated. Just this one, right? Because this is dx squared divided by 2. And the plus some constant. So we know the form is 1 plus c exponential minus x squared over 2. And when x is 0, the number is minus 1. So c is minus 2. Okay, so we have the result. Okay, and they ask about x go to negative infinity. So this term will be 0. So we choose what? We choose B. The answer should be B. B. Okay, then we go to 45. Okay, 45 is a little bit tricky. Since he asks you to solve the transcendental equation. So basically, you have two ways. The first way is you can basically you only have one way. The only way is that you just plot the function and think how many answers. Okay. But I guess this question need to be think carefully that suppose we only solve cosine 2x equal to x. Suppose this is 1. Since the maximum of the cosine function is 1, so the only possibility that the two curves intersect with each other is in this small region. Okay. So 1 to 1, then this is x. And the cosine, this is pi. This is pi over 2. So for the cosine x, for cosine x, we only have one intersection at the right hand side. For the cosine 2x, the pi over 2 will be minus 1. So we still have 1. But for the cosine 3x, or I should say this. So this is the function of the cosine, right? This is basically one small cycle of the the half the small one period. And if this is 1, then then it can if one is here, then basically you can have two intersection points. So the intersection points should close to the 1 divided by how many periods times 2. And each, so basically if cosine 7 is 97x, the period is 2 pi over 97. So the answer is 2 minus 2 pi 97. 2 pi over 97. So basically it's 97 over pi. And you can calculate, basically it's close to 31. This is the way you can solve it. But when the first time you solve it, you need to plot the function and get this feeling. So I think the 45, this problem is somewhat very tricky, that it's hard to solve it in the first when you are first time see this question. Okay, 46. 46 is very easy question that maybe everyone already. This is very stupid. That he said there is a later 9, and when this is the 2, the velocity of this x direction is 2, and there is this 3, and he asked about the vy. And this is easy, that because you know the Pythagorean principle. So this side can be computed by 81 minus 7 is 6 times square root of 2. So basically you know that 6 times square root of 2 plus dx square plus 3 minus dy square should maintain the length. So you get the 12 square root of 2 dx minus 6 dy should be 0. We neglect the dx square term and dy square term. So we get and the dx over dt is 2. So we divide dt. So dy over dt is 2 times square root of 2 times 2. So 4 square root of 2. This is a simple question that we choose C. And 47. So this is also the standard analysis question. He asked about if x belongs to rational, is 3x squared, and if x belongs to irrational, this is minus 5x squared. Okay, so which point is continuous? Okay, so any points of R can be approximated by a sequence of rational functions and a sequence of irrational points. Okay. So if I approximate a point A by the rational points, so basically I use Sn, and each Sn belongs to Q, and I use this approximate to A. Then function of Xn should approximate to 3x squared, 3a squared. And then if I use the irrational points, approximation should be minus 5a squared. So the only points which are continuous is a squared equal to 0. So the only points a is equal to 0. So 0 is the only point which is continuous. So we say A is not correct. B may be correct. C may be correct. D are not correct. So we left 2 choices, B and C. Okay, so now f prime may exist only at s equals 0. So when x equals 0, for the rational points, it is 6x, and the x irrational point is minus 10x. So it only the same when x equals to 0. So the same process show that the x equals to 0 is also differentiable. It also exists. F prime is also exist. So the answer is B. F is continuous and differentiable only if x is equal to 0. 48 is very easy, that it asks about you the directional derivative. So the directional derivative is equal to the direction inner product with the gradient. Okay. So the normalization of the direction is 1 over 14, square root of 14, 2 over square root of 3, 3 over square root of 14 times the gradient of g. So gradient is the partial derivative of x, 6xy, partial derivative over y, partial derivative over z, and we plug the point 0, 0, pi. So go 0, 0, 1. So the answer is 3 over square root of 14. And you can easily see that this is close to the choice B, 0.8. Choose B. 49. 49 is the also a tricky problem. Permutation of 5 objects is S5. So it has 120 elements, and he asks about you the largest order. So the difficult part is what's the answer? So basically, you need to think about what is the largest permutation? What is the largest permutation that the largest order permutation of the in the permutation group? What kind of permutation is the most random one, or it need to be shuffled at most? So once you think carefully, you can get an answer. So let's solve the simple problem in S3. So in S3, the largest order is 1. Suppose we have x equals to 1, 2, 3. So basically, this is 1 change to 2, 2 change to 3, 3 change to 1. And if we square it, it becomes 2, 3, 1. If we cube, it becomes 3, 1, 2. If we go fourth, it becomes 1, 2, 3. So largest order is the largest order is 4. So in S5, the largest order should be 6. I think you need to think carefully. It's not 5, it's 6. So the answer is B. Okay, so number 50, this is simple question. If you don't know the answer, then you should study the abstract algebra and review the abstract algebra. So if I and J are two ideals in R, then common sense is I intersection J is also ideal. This can be proved by definition, because you add any x into I intersection J, then x multiple I is in I, and x multiple J is in J. So x times any element in the I intersection J will still be still in the I intersection J. Second is the I plus J is also an ideal. but the third is I times j. But I times j means that means the linear combination of Ri, Rj, I. Okay, maybe ij. I belong to I, j belong to j, but only linear combination. So in this question, the first one is this one. The second one is not an ideal because it meets a linear combination, and the third one is ideal, so it's 1 and 3. We choose D. So this problem is simple. You just ask about the basic definition and the basic results of the two-side ideal. So you can see the Hurston abstract algebra for your reference. So there is no much technique in this problem. So 51. Yeah, 这个表有 also normal basis for the column space. This is very simple, that column space. So all you need is use Gaussian elimination to find the column space. So I use the first one to cancel the second one. I add them together. And I use this one to cancel this. So I got these two, and I cancel the 0 term, and the same result, same term. So the column space is this one. Oh, okay. So you need to do the Gram-Schmidt decomposition. But in this case, we have multiple choice, so we don't have to do this. We first normalization this one, we get the square root of 6 minus 1 square root of 6 2 over square root of 6, and the sum also normal vector. So the only choice is E, because the first one is not correct, and the B choice there is a 3 independent, so it's not correct, and the C is also not correct, and the D is not normalized, so the only choice is E. So we choose E. So remember that in the subject GRE that you don't have so much time. So once you recognize the answer, then you just intermediately choose it. You cannot verify it very carefully because you don't have enough time. Okay, so I think I will solve until the 52, and we will start 53 next time, and we may solve all of them. The university department has 10 professors and will offer 20 different courses, and each professor choose 2. How many? This is basically you should remind the answer. You should remember the answer that. So 10 different boxes, 20 different courses. So we just C20 choose 18, C20 choose 2 for the first professor, C18 choose 2 for the second professor, C16 choose 2 for the second professor, C22. So you write it carefully. You can get 20 factorial, 2 factorial, 18 factorial, 18 factorial, 16 factorial, 2 factorial, keep going. So this term will cancel. So finally you get the 20 factorial times 2 factorial 10th power, and then it's 20 factorial over 2 to the 10. So we choose A. There's no much special here. The answer is just A. Okay, I will. So be sure that you subscribe to my channel, and if you find I did something wrong, just leave a comment below, and I will see you guys in the next time.